everybody, welcome back to a brand new video. I hope you're excited for today's video because I definitely am, since we are officially starting to cover content in our AP Physics journey. So the first chapter of AP Physics, as you know, is kinematics, and before we do anything in kinematics, there are some certain terms that we should learn about, and that's what this video and the next couple of videos will be on. In fact, today we're going to be talking about two very big terms, and all of these terms in fact will be fundamental and they're essential for us to understand before moving on in this first chapter of kinematics. But today's video will specifically focus on distance and displacement. So we're going to compare and contrast them and see exactly what distance and what displacement are. So without further delay, let's get started. So before I start, I do want to say that I'll be writing on my iPad, and you'll see my iPad screen, and obviously it'll be displayed to you. So I'll be writing over here, so you'll see me looking down a lot. So that's sorry if you are bothered by that I'm not always looking straight at the camera. Okay, so let me just get this started. I think distance is a really common word, like we use it like daily really. Maybe displacement might be a new term for some of us, but anyways, so I think we'll realize if it's new or not once we start. So first off, let's talk about distance, probably the word that most of us know about. So distance is nothing but the total ground that the object in question has covered. So distance is the total ground covered, okay? And like, let's say, for example, I start at point X, which is over here, okay? From point X, I go to point Y, and we'll say that each of these units, like from here to here, okay, all the way from here to here, we'll call that 1 meter, okay? So then this whole thing, right, would be 3 meters. Oh, sorry, I still have my vanish pen on. So these 3 blocks, right, they'll be 3 meters, right? So the total distance, or the total ground that I've covered, will be 3 meters. So the total distance here in this example is equal to 3 meters. 3 meters, okay? So that's what distance is. Now, displacement, okay, displacement, let me just write that. This might be a new term for some of us, but it's really easy. Displacement is nothing but your net change in position. So displacement is the net change in position, okay? Well, let me rewrite that. It's kind of bad handwriting. I apologize for the bad handwriting. Net change in position, okay? So a lot of times people, like when starting out in physics, a lot of people get these distance and displacement a little bit confused, because sometimes, you know, when you're starting out, to your brain they feel like very similar things, but they're not. And to understand this better, let's take an example. Okay, so say I'm here at point X. From here I walk, let's say 3 units to the right over here to Y. Okay, from Y, then I decide, you know what, I'm going to walk back, but I don't want to go back to my starting position. So then I just decide that I'll walk all the way to my starting position, and then 2 more extra blocks to the left, okay? And then I end up over here, and we'll call this point z. Okay, and we're asked to find the displacement in this case. So since anything that whenever we are finding a net change, we usually only consider our initial and final positions, right? So in this diagram right here, this diagram, what is my initial position? Right, my initial position is at here, right, at point X. This is my initial position, and Z is my final position. Okay, and so what is my final position with respect to my initial position, right? So essentially what I'm trying to say here is that this is my final position right here. Okay, what is this in relation to this? Okay, because we're trying to find the net change. So if we take each of these blocks as 1 meter, then point C is 2 meters to the west or to the left of point X, right? So what is my displacement? My displacement in this case, by the way, displacement is usually denoted as the variable x, okay? I should have changed this variable to a different letter, but anyways, now we know that displacement is usually denoted by the variable x. So here our displacement was 2 units, or sorry, my bad. Our units here were meters. So 2 meters to the west. Okay, 2 meters to the west. So that's our displacement, right? But we can also have another example. Let's say I start at over here, okay, at point A, and then I travel 3 units to the right, and then I get over here to point B. Okay, so what is my displacement in this case? And we're still taking each of these blocks as 1 meter. Okay, so then this total distance, or this total, in this case, the total distance is 3 meters. And the total displacement is also 3 meters. Right? Because this is my final position. This is x final. And point A is my x initial position, right? So in this case, initial and final, the distance happens to be equal to the displacement. But if we go up here, right, and we find the total distance we traveled, that will be, let me see. So it'll be 1, 2, 3, and then we go back 3, so 6, 7, 8, right? Here in this case, the total distance is equal to, what was it? 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8. 8 meters, right? I counted that right? 1, 2, 3, 4, 6, 7. Yes. So the total distance is 8 meters, right? If you look over here, it shows that the total distance is 8 meters, but when you look over here to displacement, the displacement we got was 2 meters. So there's a clear difference here between 8 and between the 2. Also, one more major difference that I'd like to point out is that here in the distance, we only have the magnitude, as in the numerical value, which is 8. But with the displacement, right? With the displacement, we have 2, which is a numerical value, or it's also called the magnitude, and we also have the direction, which is west. So any quantity like distance here, which gives us only the magnitude, is called a scalar quantity. Okay, this is called a scalar quantity. And scalar quantities are all the quantities that calculate only for the magnitude, and we will be encountering some more scalar quantities as we go farther, as we learn more and more new things in physics. And any quantity that gives us both the magnitude and the direction, like displacement over here, right? This is called a vector quantity. Oops, sorry, let me redo that. It's a little messy. So it's called a vector quantity. Okay, and vector quantities are all the quantities that have or calculate for both direction and magnitude. Alright, so that was displacement versus your distance, and I hope you understood what we did today, because this is really, really important going forwards. We're going to use this concept a lot as we go forwards too. If you have any questions, leave them in the comments. I will try my best to get to them, and I will see you in my next video. Bye!